Hidden away within the confines of a heavily guarded facility, the JCB Hydrogen Engine represents a leap forward in automotive propulsion. This groundbreaking invention harnesses the immense power of hydrogen, a resource once considered impractical, but now poised to revolutionize the very essence of electric vehicles. As we explore the intricacies of this marvel, we confront the shortcomings that have plagued traditional EVs for years. Range anxiety, a thing of the past. Long hours spent waiting for batteries to charge, a distant memory. The JCB Hydrogen Engine offers a seamless and efficient alternative that threatens to render conventional electric vehicles obsolete. Electric engines are just insufficient for a company like JCB, which specializes in the production of engines for heavy machines. This is due to the inability of electric engines to provide the type of power required by these big machinery. In heavy lifting equipment, replacing diesel engines with batteries means trading power for fewer ecologically hazardous pollutants. Other brands, honestly, can afford to make that compromise, but not JCB. Certain occupations, such as building and agriculture, need the use of powerful machinery. As a result, JCB saw the need for an unusual solution to their predicament. They knew they needed to build ecologically friendly engines in some way, but they couldn't afford to compromise engine power. To meet these requirements, JCB began work in 2020 on producing hydrogen-powered engines with equal power potentials as diesel engines, but this time they were ecologically beneficial. Even though JCB is yet to begin mass manufacture of hydrogen engines, they have achieved tremendous progress in only a few years. Hydrogen engines are the future of JCB, and they are leading the way. Small devices that do not need a lot of energy may be powered by electric engines. Technological advancements, such as the production of electric vehicles, have shown this. JCB leads the way in hydrogen fuel integration for improved performance. How is this even possible? JCB has already tested many fuel alternatives to reach this result. In 2019, JCB installed a Nissan fuel cell in a prototype 20-ton X-Series excavator. Following a series of research, the business determined that battery cells were too difficult and costly for heavy machinery. What is the difference between a diesel-powered JCB and a hydrogen-powered JCB? The JCB hydrogen combustion engine has a similar appearance to diesel engines. When driving, drivers would detect no change. And according to Ryan Ballard, JCB's head of engine development, the only difference drivers would notice is that the engine is less loud, which is a good thing. Because hydrogen engines are so similar to diesel engines, JCB engineers throughout the globe should have no trouble developing them. JCB's hydrogen engines have the same capacity and bottom end as diesel engines. The standard diesel injectors are replaced by hydrogen injectors and spark plugs in the hydrogen engine. Because hydrogen has a lower density than diesel, it is injected at lower temperatures and pressures than diesel engines. This engine, unlike diesel engines, does not self-ignite, which is why a spark plug is provided to ignite the gasoline. Inside the engine, a precise mixture of hydrogen and air is required for combustion to occur. Tim estimates that this homogeneous mixing will be attained in 28 milliseconds. To accomplish this, a high-efficiency turbocharger with minimal inertia is used to rapidly introduce additional air into the engine. Nitric oxide may be produced by burning air at a certain temperature. However, due to the low temperature and pressure of combustion in the hydrogen engine, these pollutants are not produced. Finally, the hydrogen engine is a much more environmentally friendly alternative to diesel engines. Inside the engine, there is no carbon combustion, hence there are no CO2 emissions. Now you must be thinking, what is a hydrogen engine's byproduct? Is it liquid water or steam? Steam is produced as a byproduct of the combustion process within the engine and exits via the exhaust. Ryan Ballard refers to this steam as dry steam, and it is handled inside the engine using a special lubricant. This oil does not emulsify in water and keeps water vapor out of the engine. A bowser is a tank that transports gasoline to heavy-duty equipment. This similar mechanism is used in hydrogen combustion engines, and JCB has already constructed a hydrogen storage tank capable of holding 100 kilograms of hydrogen. It is intended to run at 500 bar pressure with a machine pressure of 350 bar. Because it is primarily a decantation operation, refilling does not need a pump. As a result, an empty tank may be comfortably filled with hydrogen fuel in only a few minutes. However, procuring hydrogen fuel is harder than refilling. This has to be the most difficult problem when transitioning from diesel-powered engines to hydrogen fuel. While diesel fuel is widely accessible, where do we acquire the hydrogen fuel to power these new engines? The most abundant material on the planet, hydrogen, is not widely accessible in its pure form, and only pure hydrogen may be utilized as fuel. However, it is fair to assume that JCB has its sights set on the future. After developing a clean hydrogen-powered engine, the next issue will be making green hydrogen widely accessible. On a more positive note, numerous nations have begun to make strides in the generation of hydrogen fuel. While we are still a long way from achieving carbon neutrality, it is apparent that progress is being made. But why bother following the hydrogen fuel trail? Toyota is also a firm believer in a hydrogen-fueled automotive future, so JCB is not the first to see a hydrogen-dominated fleet. We think this is due to the many advantages of hydrogen engines. Aside from the unavailability of hydrogen fuel, we are certain that hydrogen engines outperform diesel engines. We now have a far cleaner alternative to diesel and gasoline with hydrogen fuel. Hydrogen combustion engines produce no net CO2 emissions. The chemical process that occurs within the engine is carbon-free, with dry steam as a byproduct. JCB's revolutionary move from conventional fuel to hydrogen-powered is a big step toward developing net zero emission hydrogen-fueled combustion engines that do not need considerable driver adaptation. The trucks work in the same manner as those powered by diesel engines. Although JCB claims that hydrogen engines are somewhat more efficient, electric batteries capable of delivering the needed quantity of energy to run large equipment are often excessively heavy and take up much too much room. JCB engineers feel that hydrogen-powered machines are the way of the future, and although we were initially doubtful about how it would work, their new engines have gone a long way toward convincing us. Hydrogen engines are clearly a possibility. It's only a question of building the infrastructure, proving its durability, and gaining widespread market acceptance. In Europe, the transportation sector is considering hydrogen as an EV option. In addition, more refueling stations are being built in France and Germany. Remember to like this video and subscribe to our channel to stay up to date with the latest developments in the ever-evolving world of automotive innovation. Thank you for joining us, and we'll see you in the next exciting chapter. Thank you for joining us on this exhilarating exploration of Tesla's hairpin engine and its potential to revolutionize the EV industry. Together, let us embrace the limitless possibilities that lie ahead as we strive to build a sustainable and electrifying future.